Let's find the area of a triangle. Find the area of the triangle below. Be sure to include the correct unit in your answer. Okay. Notice the base is actually 19 feet. The height is actually 6 feet. Let's reorient this triangle. Let's turn it around and let's draw the triangle like this. And so there's really, the height of the triangle is 6 feet. And the base of the triangle is 19 feet. And that's all you really need. Because we know that the area of a triangle is what? 1/2 the base times height. So area is now equal to be 1/2 the base, which is 19 feet, times the height, which is 6. Now I recommend that you reassociate this and do 1/2 times 6 first, and then do 19, because then that's just 3 times 19, which is 57. Now, what's 57 what? Is it 57 banana slugs? Of course not. It's 57 square feet. So make sure you write the units on your paper. The area of the triangle is 57 square feet. A complete sentence is always nice. Let's look at this problem over here. It says the composition of two functions, the domain and range. The functions f and g are defined in the figure below. So g is actually mapping these numbers, right? These are your inputs. Your inputs is 0, 2, 3, 4, and then 8. And it maps it to an output. And that output is 0, 2, 3, 4, and 8. Now, where do these go? If you're trying to figure out the composition of f composed with g, g goes first, not f. G goes first. F is second, okay? So after g composes, after g takes their input and puts it to an output, we take these outputs, and these outputs over here become the inputs of f. So I always look at this as a relay. I don't know if you ever watch track and field, but if you see like the 4x100 meter relay, it's sort of like passing a baton. So 4 passes to 0, and then 0 passes to 1. So it's sort of a relay. 4 goes to 0, and then 0 goes to 1. All right, enough said. Let's find the domain of f composed with g. Now you gotta just remember, this goes first. So you need the inputs that go into g. So when we write f composed with g of x, remember that's really f of g of x. And you can see that g of x goes first. Right here, this goes first. Once you realize that goes first, then this must go second. All right. Domain of f composed with g. Let's write the set. The domain, I use a little bit of advanced notation. The domain of f composed with g. I need to write a set. It's not difficult. We just got to write these particular numbers over here. Those numbers are going to be part of the domain. So 0, 2, 3, 4, and 8. That is the domain. Let's figure out the range. What is the output? What are your final outputs? The range of f composed with g is equal to your output is the very end here. It's got to be the 1, 8, and 9. And there you go. You're done. Finding a difference quotient for a linear or quadratic function. This is called a difference quotient. In this class, that doesn't make a whole lot of sense. There's a difference in the numerator, and it's divided by h. And so when you simplify this, you get a quotient, which is an answer to a division problem. Now, in reality, what this has to do with math and science is this is later called a rate of change. In fact, not just a rate of change, it is actually called the average rate of change. And so when you make it to calculus of all sorts, like business calc or biology calculus or engineering calculus, we change this and not call it the difference quotient anymore. We call it the average rate of change. Now, for this class, we do develop the elementary computation for it. So this problem is about expressions. So let's change the way this expression looks. Here's an expression, and then we simply substitute. What is f of x plus h? So whenever you see an x, you're just going to put parentheses x plus h. And then minus 5. Now I am going to go back and highlight this part. This says minus f of x. So we need to subtract that function. But what is that function? That function is in parentheses, 4x squared minus 3x minus 5. Do not forget the parentheses. Those are necessary. Your function is an entire quantity, so you must put parentheses here and here in order to get the problem right. Now, let's divide that all by this letter h. Now this becomes a reaction problem. And so you could react to this and just start writing really fast. You know, you have a lot of formulas memorized, and then this becomes algebra, and you're just simplifying things. It's no big deal. All right. If you are going to slash, I recommend that you slash very, very lightly. So you do have to be very, very careful here. Let's see what we have left. The 4x squares reduce. Those reduce to 0 or cancel out to 0. You do have an 8x times h. You also have a 4h squared. I said 4h squared. Your negative 3x plus 3x goes to 0. And then you also have a minus 3h. Your negative 5 and 5, those add up to be 0 as well. I think that's all of it, and that goes over h. So what is the common factor in the numerator? The common factor is h. And what do we have left? We have an 8x plus a 4h minus a 3 all over h. Notice that's your new expression. Your last and final expression is 8x plus 4h minus 3. All right. Ta-da! So that is the difference quotient. If you're interested in summarizing what you just wrote, you're going to say something like, therefore, f of x plus h minus f of x over h is indeed equal to what? 8x plus 4h minus 3. Now, this computation doesn't have a whole lot of meaning in this class, but in a calculus course, it will have a significant amount of meaning. That's a 4, by the way. I apologize. It looks too sloppy. So, circle that. That'll be fine. Finding a difference quotient for a rational function. So there's a difference in the numerator, and it's divided by h. So when you simplify this expression, it becomes a quotient. So that's why we call it a difference quotient. Unfortunately, this name doesn't have very good meaning in a calculus course. So when you get to calculus, this will be called the average rate of change. Okay. For now, it is just called the difference quotient. We're just developing the elementary computation in this course. When you extend this to the calculus course, it will be called the average rate of change. Let's simplify expressions or manipulate this expression. We're going to manipulate this expression here. Put that all over what? All over h. Let's substitute. Whenever you see an x and your input is now x plus h, we're going to put an x plus h there. So it really makes sense to put parentheses. If you're very, very careful, you put parentheses over what? Parentheses x plus h minus 9. And then we want to subtract f of x. What is f of x? X over x minus 9. Now, put that all over what? Put that all over h. And I apologize, this equal sign should be lower. It should be right here. Now, what do you do with the numerator? I mean, it simply is common denominator. So you have an x plus h minus 9, and we want to subtract two fractions. So we need common denominator. So I'm going to multiply this one by x minus 9 over x minus 9. That's another name for 1. Now everything gets parentheses, right? All numerators and denominators have invisible parentheses. Minus x over x minus 9 times what now? Times x plus h minus 9 over what? X plus h minus 9. And as usual, all the numerators and denominators have invisible parentheses. Put that all over h. Okay, now let's simplify things. What's the next expression? I'm going to put it way up here. And we have x squared minus 9x plus xh minus 9h. Now you do have common denominator, so I'm going to put, let's see here, minus parentheses x squared plus xh, and then plus 9x. Nope, sorry, I take that back. Minus 9x, minus 9x. Yeah, that's correct. What's the common denominator? The common denominator for the numerator expression is simply x minus 9 times what? X plus h minus 9. Now, instead of divide by h, I'm actually going to multiply by 1 over h. I hope you guys can see that. I'll make that clearer on the next line. I'm going to, instead of divide by h, I'm going to multiply by 1 over h. So let's simplify. X squared minus x squared will get you 0. Okay. The x times h minus x times h will get you 0. The subtract 9x, add 9x will also get you 0. So what's left in the numerator? I just see a negative 9h. Yeah. All over what? All over x minus 9 times x plus h minus 9 times it by 1 over h. Remember, divide by h really means multiply by 1 over h. So I did that on the previous slide. That says multiply by 1 over h. Well, that's nice. The h's are factors here, so those reduce. So what are you left with? Negative 1 over x minus 9 times x plus h minus 9. Ta-da! And that is your difference quotient, or your expression for the average rate of change. For the real valued functions, g of x equals x minus 6 over x minus 3, and h of x equals 2x plus 1, find the composition g composed with h and specify its domain using interval notation. Our goal is to find this function and make it into a formula. Remember that h goes first. In this notation, when we compose g composed with h of x, h is actually the first function. The second function is called g. Well, why don't we work on this? If we work on this, then we should be able to find this part as well, which is the domain. So why don't we break this into two problems? Let's break this as the first problem, and then this one is the second. Let's find the expression g composed of h of x. Well, that by definition is g composed with h of x, or g of h of x. And now we substitute for h of x. H of x is 2x plus 1. So at this moment, it seems like x can be any real number. But when we get to the next step here, which is g, we're going to apply g, and the input is 2x minus 1. So wherever we see an x up here, we're going to put parentheses 2x plus 1. Same thing with here, parentheses 2x plus 1, because we're going to put 2x plus 1 in there. So our input now is 2x plus 1. The output says it must look like this. 2x plus 1 minus 6 all over 2x plus 1 minus 3. All right, simplify. We get 2x minus 5 is now in the numerator, and now we have 2x minus 2 in the denominator. So we have 2 like that. That's 2x minus 2, right? 2 times parentheses x minus 1. Now we all know that we cannot divide by 0. So we want to say something like this. The denominator, 2 times x minus 1, can't be 0. That means x cannot be 1. So we got both parts. So this is the end of the first part. And then this is the beginning of the second part. Now we just got to write things carefully. So what is the conclusion for the first part? Therefore, we do have a function, g composed of h of x, is 2x minus 5 over 2 times x minus 1. And of course, x can't be 1. That's the answer to the first part. Now, what is the second part? The second part says, find a domain and write it in interval notation. All right. What is the domain of g composed with h? Well, our restriction is that x can't be 1. Everything else is fine. So we're going to write parentheses negative infinity up to 1, union parentheses 1 to infinity. So it's the entire real number line except 1. That's how you read that interval notation from left to right. Let's circle that, and that is the answer to the second part. So that was the answer to the first part. This is the answer to the second part. Word problem involving composition of two functions. The temperature, capital T of D, in degrees Fahrenheit in terms of the Celsius temperature D is given by T of D is equal to 9/5 D plus 32. The temperature, C of V in degrees Celsius in terms of the Kelvin temperature V is given by C of V is equal to V minus 273. Write a formula for the temperature F of V in terms, write a formula for the temperature F of V in degrees Fahrenheit in terms of the Kelvin temperature V. It is not necessary to simplify. So there is a relay going on. We want our first input value to be what? We want our first input out value to be a Kelvin temperature. So let's say we're going to start with a V, and we're going to apply a function to V, whatever that Kelvin temperature is going to be. We're going to apply the function C to it. And when we do that, we'll eventually get an output that feeds into a Celsius situation. In fact, we'll call that C of V. The output is C of V. And then from C of V, we're going to perform another relay, and we want to make sure we go to Fahrenheit. and that relay is going to be called T. So when you apply T to C of V, what you end up getting is T composed with C, T composed with C of V. And that's how we write that. So what are we really trying to find? We're trying to find f of v, but what is f of v? F of v becomes a composition. F of v is going to be T composed with C of v. So we're going to define f of v to be T composed with C of v. Now we just substitute. Now that we understand what all those English words are saying, we're going to use mathematical symbols to provide the formula or provide the function or provide the model to this problem. What is C of v? C of v is v minus 273. Now we're going to use the function t. T says take 9/5, put parentheses, v minus 273, and then finally add 32. It says it's not necessary to simplify, so an acceptable answer here would be, therefore, f of v is this function, 9/5 v minus 273 plus 32. So just do a little recap here. If you put a Kelvin temperature in this function, your output's going to be in Fahrenheit. Awesome. Nope, I forgot something here. I need to put the units. The units are what? Fahrenheit degrees. Let's talk money and business. Word problem involving composition of two functions. Suppose the value R of D dollars in euros is given by R of D is equal to 8/9 D. The cost, P of N in dollars to purchase and ship N purses is given by P of N is equal to 88 times N plus 23. Write a formula for the cost, Q of N, in euros to purchase and ship N purses. Try to say ship N purses 10 times fast. According to what's said here, our independent variable must be N, and N is the number of purses. Right here, N is the number of purses. So if we start with purses, and then we come out with the cost to ship those purses in, let's say, US dollars, then what we want to do is now convert those into euro dollars. What we need to find is actually Q of N. So what is Q of N? Q of N is simply going to be R composed with P of N. And remember that P goes first and R goes second. Let's substitute R of P of N. And what is P of N? P of N is 88N plus 23. And what is R? R, whenever you see a D, you're going to put parentheses 88N plus 23. It says if your input is D, then we go 8/9 times D. Well, if your input is 88N plus 23, then we go 8/9 times 88N plus 23. Just make sure you put parentheses. So what do I mean by that? Let's write it out. 8/9 parentheses 88N plus 23. Period. What is our new formula? Therefore, Q of N is going to be this model here, this linear model. 8/9 times the quantity 88n plus 23. You might as well circle your work too. And that is right here, your final answer. Oh, I forgot something. I forgot to put the units here. Make sure you put the units. Our final answer actually has the units of euros. Let's do some physics. Word problem involving composition of two functions. The braking distance, d of v, in meters, for a certain car moving at velocity v in meters per second is given by d of v is equal to v squared over 34, which is a quadratic function. The car's velocity, b of d in meters per second, t seconds after starting, is given by b of t is equal to 5t. Write a formula for the braking distance s of t in meters after t seconds. It is not necessary to simplify. So there's a relay going on. What we want is actually start with the time t, and then there's a function that takes that input value and applies the input value and turn it into an output value. That output value is actually called b of t. Then from there, you're going to take that b of t, which is the velocity, the car's velocity, and then we're going to use the car's velocity to determine the braking distance. And how do we do that? Well, we're going to apply a different mapping here, and that mapping is actually called d. And so your final output is going to be d, composed with what? Composed with b of t. So there's really a relay going on. So you take your input t, apply b first, and then after that, that output becomes the input for d, so apply d second. All right, let's write this with mathematical symbols. We want to find s of t. S of t is going to be defined as the composition d composed with what? Composed with b of t. There we go. Let's substitute. By definition, what does that mean? The b goes first. D composed with b of t. The b goes first. What is b of t? B of t is 5t. And then what does D say to do? D says, take your input, square it, and divide it by 34. D says, take your input, square it, and divide it by 34. D says, take your input, square it, so I need to put parentheses, 5t, square it, and then divide it by 34. It doesn't say we need to simplify, so we just need to write what our final function is. Therefore, s of t is equal to 5t quantity squared over 34. What's really cool about this is that if you input the time, your final answer is going to give you what? It's going to give you a distance, a braking distance in meters. So this is actually in meters if you're interested. Why don't we write that? Units are very helpful. Meters, and then period. Solving a polynomial inequality. Solve the following inequality. X cubed minus 8x squared greater than negative 15x. Write your answer as an interval or union of intervals. The first thing we want to do is actually see if we want this polynomial to be positive or negative. We don't like the way this is written. So let's balance this polynomial and make it look nice. We balance it so that we could see one polynomial And that one polynomial is now greater than 0. Now, instinctively, you'll probably take out the greatest common factor. So x times x squared minus 8x plus 15. And now you have a trinomial, and you're probably going to react to that as well. You're just going to factor. Make sure you check your factoring. That is correct. I checked it. And now we might as well find the zeros of the polynomial. What polynomial am I talking about? We want to find the zeros of this polynomial here. So if you set this equal to 0, we end up getting this nice factorization that you could see on your left, and we could find the zeros. We're going to take those zeros and put them on the number line. We're going to put them on an x number line. Now, this is not going to be to scale, but I do need to put them in order. So it's going to be 0, 3, and 5. So 0, 3, and then 5. And I apologize. Like I said, this is not to scale. The scale is really far off. So why don't I fix that? There, that's a little bit better. Now what we're going to do is test around those zeros. So remember the domain for a polynomial is all real numbers. The only thing you can't pick are 0, 3, and 5. Now, we already know those are not included in our answer, or is not included in our solution. We cannot shade 0, 3, and 5. Remember, for inequalities, you're trying to shade the true side. So why don't we test? What am I testing here? I'm going to test this equivalent polynomial right there. I'm going to test an x value. Let's test x equals negative 1,000. So we want to know is when you put negative 1,000 into the polynomial, is it going to be a true inequality or a false inequality? You could easily see that you get negative 1,000, and then you have negative 1,005, and then you have to multiply it by what? Negative 1,003. Now, I'm not really concerned about the numbers so much. I just want to know, is this greater than 0? In other words, is this inequality true or false? Negative times a negative times a negative is still negative. Is a negative number greater than 0? So what I'm doing is actually conceptually, I'm just going to do this. Negative times a negative times a negative. Is this greater than 0? And the answer is false. Of course not. A negative number is not greater than 0. So where am I going to put the false? I'm actually going to put it back on top of the number line. Now we do the same thing. We need to test a number between 0 and 3. Why don't we try testing x equals 1? So we get a positive number times a negative number times a negative number. Is this greater than 0? And the answer is true. Now this is not technically formal mathematics, so I'm putting it in a bubble. This is what I do in my head. This is bubble math. But it's okay if you write, p times n greater than 0. I will understand what you're trying to do. The key is that you actually tell me what you test. That's really, really important because you get to choose here. You could have chose, 2 and 7/8 here if you wanted to. You could have chose 2 and 7/8 in this region. You could have chosen, x to be negative 6,354,632,000,000 in the negative direction, okay? So now let's pick a number between 3 and 4 to test. Pick a number between 3 and 5 to test. Well, the obvious choice here would be what? Test x equals 4. Oh, I forgot to mark. We always shade the true side, so let's mark the true part of that number line. X equals 4. So, what do we get? We get the concept of positive times negative times the concept of positive again. Is this greater than 0? And of course not. False. More importantly, you tell me what you test. okay? And then let's put a false symbol here. So we're not going to shade the false regions. How about another x value after 5? You could pick 6 billion. If you pick 6 billion here, you should be able to see that it's true. 6 billion. Okay, you see a positive times a positive times a positive is still greater than 0. So this is obviously true. More importantly, tell me what you test. So I'm circling all those test numbers, and we know this is true. Awesome. Now, what is our final answer? We always shade the true side. We always shade the true regions. So we shade it from left to right because this is interval notation. We shade it from left to right because this is interval notation. We even have to shade this arrow. This arrow is pointing to the concept of infinity. So why don't we translate this? Once you translate this, you have the interval notation. Our answer is going to be from 0 to 3, from left to right, union 5 to the concept of infinity, from left to right. Circle your answer. Make sure you also show all this work. This work is very, very important. What work do you need to show? No, let's just say that much, right? Solving a polynomial inequality. Solve the following inequality. X cubed minus 4x squared greater than 4x minus 16. The first thing you want to do is isolate this inequality in a way that you could see a polynomial. So we want to put our polynomial on the left side of this symbol here. What equivalent inequality will we get? You should get this, x cubed minus 4x squared minus 4x plus 16. We want to know, is this inequality greater than 0? Or I'm sorry, is this polynomial greater than 0? So if you take this polynomial, and the goal now is to find the zeros. You know, if you find the zeros, it would help quite a bit in solving this inequality. It looks like we have 4 terms, and it looks like factor by grouping is going to work. So let's take an x squared here. X minus 4 here, and then we have x minus 4. Yes, factor by grouping is going to work. What is our common factor? We have x minus 4, and then what's left? We have x squared minus 4. Is this greater than 0? Why don't we take x minus 4, and we write this now as x plus 2 times the quantity x minus 2. Is this equivalent polynomial greater than 0? We're going to put those zeros on the number line. So we're going to put negative 2, 2, and 4. And this is not going to be the scale. Just keep that in mind. It's just a rough number line here. Not the scale. Got 3 zeros here. And what did we say our zeros were? We said it was negative 2, 2, and 4. And like I said, this is not the scale. This is an x number line. That's not the scale. And now we're going to test x values. Make sure you tell me what x values you test. So let's test x equals negative 1,000. You're going to get what? A concept here. You're going to get a concept of negative times a what? Times a, oh, I'm sorry, I should tell you what I'm testing. I'm going to test right here, this part of the polynomial. It's already factored. It's easier to test that way. So if you put in negative 1,000 minus 4, you get a negative. Put in negative 1,000 plus 2, you also get a negative. And then put in negative 1,000 minus 2, you also get a negative. So we have a negative times a negative times a negative. What is the concept? Well, we want to know, is this greater than 0? And the answer is false. So it's not. So we can't shade our false regions. So we'll label this. This is our false region. We do not shade that. Remember, when you're solving inequalities, you are really shading regions. How about this? What number are you going to test between -2 and 2? Ooh, what's a good number to pick in here? Ooh, it looks like an egg. Ooh, what number are you going to pick here? You're going to test x equals 0. I mean, you could pick 1 and 9/10, I guess. If you want to make your life difficult, go for it. But you want to test x equals 0 there. And once again, we're going to test the factored form of the polynomial. And we get concepts. We get a negative, we get a positive, and then we get a negative. And we want to know, is that greater than 0? And the answer is true. More importantly, tell me what you're testing. That is important work. And we do a similar thing here. Test x equals 3. I'm going to do the testing in my head now. Negative times a positive times a positive. That is negative times a positive times a positive. It's still a negative, so it's not greater than 0. It's going to be false here. How about picking x to be 1,000? So make sure you show me your test, and then apply your concepts. Positive times a positive times a positive. Is that greater than 0? Yes, it is. So that is true. So final answer. Well, we got to write this as a union of intervals from left to right. Well, first, shade your true regions. Shade the true regions. Do we shade -2 and 2? And the answer is no. This says don't include your zeros, right? Don't include the zeros of the polynomial. Okay, don't include the zeros of your polynomial. If it had greater than or equal to, you would then shade the zeros of your polynomial. But we don't. We don't have an equal symbol. What other true region do we need to shade? We need to shade here. Good. And then shade the arrow, because we are going to point to the concept of infinity. So our final answer is -2 to 2 union 4 to the concept of infinity. That is our final answer. Make sure you show your work, nice and neat. Solve the following inequality. This is actually a rational inequality. There's a rational function on the left side of the inequality, and there's a rational function on the right side of the inequality. So we already know that x can't be 9. We gotta make a note of that. X can't be 9. So we'll not test 9, and we cannot test what other number? We also can't test x equals 6. Now our goal, it would be nice to put a function on the left side of that inequality, and then put a more obvious function on the right side of the inequality. So why don't we rewrite this inequality to be this: -1 over x minus 6, subtract 2, 9 minus x, and that is now less than 0. So on the left side of the inequality, we have a function. You know, it has a function with two different denominators. On the right side of the inequality, we have the constant function called the 0 function. That's a nice function to compare. Now our goal is, what is this? We should be able to figure this out. Well, why don't we subtract two fractions? How do we subtract two fractions? We use common denominator. -1. Nope. Let's try -1. X minus 6 times. Let's put a 9 minus x here over what? 9 minus x here. We're multiplying by 1 minus 2 over 9 minus x. Here we have to multiply by 1 as well. We're going to multiply by x minus 6 over x minus 6. And remember, every single numerator and denominator has invisible parentheses. So you got to remember to put them where parentheses are deserved. Let's simplify this. Oh, we want to know if this is in fact less than 0. Let's simplify this. we have an x minus 9 here minus parentheses 2x minus 12 here. Put this all over the common denominator, which is 9 minus x times the quantity x minus 6. Is this, in fact, less than 0? Let's find out. I'm going to write this up here. Let's simplify things a little bit. We have an opposite of x in the numerator, and then we have a plus 3. All over what? A quantity 9 minus x times the quantity x minus 6. Now, so we have two vertical asymptotes, and we also have a 0. We have a 0 of the rational function. What is the rational function we're looking at? R of x is equal to negative x plus 3, and then 9 minus x, x minus 6. So we have two vertical asymptotes, but more importantly, we have a 0. Let's find that 0. If you put 0 in here, it's not a total surprise. The only way we get a 0 is if we can get a 0 in the numerator. So what is that 0? X is 3, right? So we have a 0 at x equals 3. And we have vertical asymptotes at x equals 9 and x equals 6. Now I'm going to test things on a number line. Keep in mind this is not the scale. I do need everything in order. We said what? 3, 6, and 9? So our 0 is 3. Our vertical asymptotes are 6 and 9. And we want to test this inequality. You could test the original inequality, but it makes sense to test it in factored form. So I'm going to pick on this one up here. I'm going to pick on this inequality up here, which I'm going to call triple star. So I'm going to test it in there. So pick a x value that is far less than 3 and in the domain of that rational function. Well, just pick 0, right? Why don't we test x equals 0? And if you test x equals 0, you get the numerator to be what? You get the numerator to be positive, and then we have a positive times a negative. And we want to know, is this less than 0? Is this true or false? This is true. So make sure you tell me what you're testing, and then realize you label your true regions, because we're going to shade those. We definitely want to shade our true regions. What else can we test? In a similar fashion, oh, I guess I should bubble this. This is what I call bubble math. It's not really mathematics. It's just a bunch of concepts in a bubble. Let's test x equals 4. So I get a negative in the numerator, and then I get a positive, and then a negative again. Is this less than 0? Let's double check that. Yeah, that's false. Once again, make sure you tell me what you pick. And this is false. So then we translate this false and put it up here and label that region as a false region. We are not going to shade that region of the number line. How about here? Let's test x equals 7. I get a lot of positive, but the numerator is negative. So I got a negative over a positive times a positive. And is this less than 0? And the answer is true. Bubble math. Lots of bubble math here. Last one, pick a large x value. Test, I don't know, x equals 6 billion. So we put 6 billion in here. We get a negative over a what? Negative times a positive. Is this less than 0? And the answer is false. Once again, make sure you tell me what you test. Here's some bubble math. And this is false. Alright, final answer is shade all the true regions. Let's shade all the true regions. Shade this part of the number line. Then you always shade from left to right. Left to right, left to right, left to right, left to right. Ooh. Can we include 3? And the answer is no. We can't include 3. That will not give us a true inequality. And that's it. So let's write our final answer. Let's make it stand out. Let's say negative infinity up to what? 3 union a 6 and a 9, and then close it off. So there's our final answer. Make sure you show your work, show lots of it, try to be as neat as possible.